Jeff, so everybody, welcome to the first in a long time in-person AZ Water Luncheon. I'm glad you guys could all make it. Yay, it's nice to be back in person. So let me see, maybe I'm not gonna use it. What do you think? Maybe we're not, okay. Is it gonna go?
This is why we can't have nice things.
This is why we can't have nice things. Well, hold on.
This is your gig.
So tentatively, we're seeking permission from AZ Water to have our January luncheon. So tentatively, we're set for January 6th, and we're going to be here at the water campus. The town of Marana is going to come talk about phase 1 water reclamation facility and recharge basins. I'm not quite sure if it's going to be Stephen and Mike, or just Mike, or just Stephen. They haven't committed yet. But sponsors will be PCL and Corolla for that event. So today, can you do next slide? I don't think this works. I'm not sure with this. I just want to tell everyone that we're really lucky to get this venue. I think we've got it because nobody's meeting in person. But in any case, there's just a few rules that Pima County has policy that we have to be vaccinated to attend in person, and that you need to be wearing your mask. You know, not while you're eating, of course, or drinking, and we've given you each a separate table, so you're kind of supposed to be spaced out on your separate tables. So for now, we're ordering boxed lunches because we can't do buffet with the COVID. So we're going to be limiting people to registering ahead of time, getting the boxed lunch, and coming. No last minute walk-ins at the door. So that's the deal for us. Next slide. PDH certificates are available for you. And I'm not sure if we have a very current email list to send out and notify people we're doing stuff. So if you want to be on the email list, go ahead and drop us off a card when you leave on the table. That would be great.
If you want a PDH, let me know.
Oh yeah,
I'll handle those.
at the back table. So that's about it, unless Erin, you've got something you want to announce?
We're doing a tree planting event on Saturday from 9 to 11 and down in Sunnyside, if anybody's interested. Just as a community service type thing. So if you're Tucson Clean and Beautiful, and you can go online and register if you're interested. We'd love to have additional hands to dig holes.
Cool. So anyone get with Erin if you're interested. Next slide. So we'll go ahead and start today. Our sponsors are HDR and Coombs Hopkins Company. Thank you very much for sponsoring and for attending. Today, Jeff is going to be our speaker. And I guess we all kind of know Jeff for a little bit, right? He's been with the wastewater industry for 25 years as a professional, graduate of the U of A. And as deputy director, he oversees treatment and research and innovation for Pima County. So, Jeff.
Thanks. And this one's not working, you okay?
Yeah, hold on. Let me get this going.
I only pick projects that I've been working on for like the last 5 years, right? I didn't go back too far. We've done a lot of stuff in our research innovation, and a lot of stuff that we do. When we developed this water campus in the West Center, our goal was to really train the next generation of environmental scientists. I always use the analogy, when NASA's looking for rocket scientists, they call MIT and Cal Poly. Those are probably the first they call. We wanted engineering firms, consultants, when they're looking for process control engineers, environmental engineers, come to Southern Arizona. So that was our goal. We do a lot of stuff conceptually, but we don't have the opportunity to take it to full scale. So that's what the West Center is about. If you're an engineering student on campus and you're doing our type of work, wastewater analysis, you've got to leave campus with a truck, a trailer, some kind of vessel to fetch water. You're probably limited to about 50 gallons because look at the weight. You've got to get that back to campus and somehow get from the parking lot up into your lab. So it really limits you to bench scale type projects. At the West Center, we can take stuff all the way up to full scale, 500,000 gallons a day piloting in that facility. And so some of our projects, like we had a TTHM project, we did that work right here at our lab here, right across from the lobby, proof of concept. We built a full scale pilot at Trace Rios. Now it's in full scale implementation at both East and West plants. The Stru Light work, we did a lot of that. That was with the university probably about 4 years ago. We have a full scale version there. And I didn't know Ali was going to be here, but Alejandra, she was our intern when we first started doing Animox research. We had a 3-year grant. We're now constructing an $8 million full-scale Aminomox project at Trace Rios to knock down ammonia levels from our centric cycling truck. We take stuff from bench scale all the way up to full scale because of the resources we have. It's quite nice. Can you get the next slide there? Yeah, this thing isn't working. Broken. All right, so here's our group. We started a group at Trace Rios. We call it, or in treatment division, it's called Research and Innovation. Alan Anton leads that group. But what we try to do is we talk to our operators, talk to our maintenance folks, and we evaluate processes. We look for things that aren't quite working well, hear feedback from our staff. We observe the problems. We try to identify solutions. We'll look at what others have done nationwide or worldwide. We evaluate which of those options is suitable for retrofitting our facility. Then we'll implement them and then measure that performance. And we do this every day. Lisa was with us yesterday with HDR. We toured some sites in California. I have a slide here in a bit. We're thinking about building a biosolids drying facility. And so far we've looked at about 5 different versions. And every site you go to, you say, boy, I really like that feature. I like that. That's horrible. I would never do that. And so all those things you see will get drawn into our final version that we construct here. Next slide. So wastewater treatment, we make 3 products, right? Wastewater comes in, we treat it, and we make high quality effluent, we make a high quality biosolids, and we have a biogas product. So those are all the processes. And so it's really become less of wastewater treatment and disposal. It's more about resource recovery and how to do that efficiently. I think you'll see over the next decade, it's going to be all about energy efficiency and energy optimization, because energy is going to skyrocket for us here in the U.S. in a bad way. So environmental stewardship, we had a 3-year grant that's turned into a 5-year process now with EPA. Looking at the Santa Cruz River, before we did these upgrades in 2014 for the ROM, that's the new Agua Nueva plant next door. If you remember our Roger Road plant, it was 1950s technology. It didn't denitrify. Ammonia came in, ammonia went out. There were hardly any aquatic life in the river because there was too much ammonia. And so they chronicled the fish, aquatic life, and all the plant species that have arisen since these plants have cleaned up the water. And that's called the Living River Project. Our partners with Sonora Institute and EPA. Next slide. Our biggest partner is Tucson Water. And so we manufacture about 65 million gallons of high quality reclaimed water every day. Every one of our facilities puts that water to beneficial use. We recharge that water to augment our aquifer and reduce the amount of groundwater we're pumping. And here next door, Agua Nueva, we call this a scalping plant. All the water we produce goes right back in the city of Tucson's reclaim system for distribution at 18 golf courses, 65 schools, parks, all these features right here. Plus we put about 4 million gallons back into the river for riparian habitat restoration. Next slide. Some of you guys remember the project that was a Water Innovation Challenge that we won and built this truck in 2017. HDR was a partner on that. CH2 of Hill and Corolla really did a lot of the design work for the processes on the truck. We took this truck to Colorado, Texas, Idaho, all over Arizona. Chandler was on Bill Nye talking about it. So we did a lot of public education and outreach, trying to demonstrate that you can take sewage and make it to treatable drinking water very easily, and it's very cost effective. If you look at the cost to make potable water, desalinization, horribly costly. It gets clean water, but it's very costly, and you have a brine reject, and it's very energy intensive. Potable reuse is the next cheapest option to make high quality water, and so we demonstrated this. The next slide. If any of you didn't get a chance to see it, that's what the trailer looked inside. We have a whole treatment process. We went on this big tour around the country with it. All this equipment is going to be put back into use. We've mounted each of those process units on individual skids at the West Center. And we just got a $2 million grant from, is it EPA, Chuck? It's EPA, right?
Yeah.
To do DPR analysis on all these log removal efficiencies for all these different processes. And so all that equipment that you saw there that was donated by manufacturers is going to be put back to use. And so we'll have a continuously operation making high quality water next door. So we're looking to kind of resurrect that activity and bottle some more water and possibly give it to brewers and stuff to keep that conversation going. Next. Here's my current nemesis, and I think we just saw struvite. Anybody know somebody who's had kidney stones or has had kidney stones? That is struvite. Kidney stones are ammonium magnesium phosphate, and it forms like this rock, right? The concentration's right. Magnesium is a limiting reagent, and so if you do have enough magnesium, you will form kidney stones if your diet's not right. And so this is what happens when it forms. Just like arteriosclerosis, it starts growing on the pipe and constricting it, constricting. So pretty soon your 12-inch pipe, maybe has a 1-inch opening, right? And so this was happening at Tres Rios. This is a modern facility when we came online in December of 2013. By January 2014, 1 month, the plant had to shut down because we were so constricted with struvite in only 1 month. How could that happen? How was that overlooked? That was a brand new facility. Well, it's a 5-stage Barton foam, and so it sequesters phosphorus. Then when it goes in the digestion process and you lyse the cells, those cells release phosphorus back into solution. And as soon as the pH comes up a little bit, it starts to precipitate wildly. And so we started searching for ways to eradicate the struvite. We were adding ferric chloride, very expensive, and ferric chloride is corrosive. It destroys all your infrastructure, just rusts stuff away. And so in 2017, we invited a firm out, Airprex, and we did a 5-week pilot demonstrating this technology. It's called a selective precipitation. We add the magnesium, the limiting reagent, and we force this precipitation and reaction to occur where we want it to, instead of in our tanks and our pipes. So next slide. So this is the end result. This is the first installation in America. And so this is with NuReSys. Swing Bioset is the manufacturer of this process. And it's actually, the technology comes out of the Netherlands. And so what we do in this tank right here, our digestive sludge that just is released from the digester, it's got ammonia at 1,000 parts per million, probably phosphorus at around 100 parts per million, and magnesium around 40. When it comes into this tower right here, we aerate it, right? So we're raising that pH, just like the struvite. We raise the pH up, so we're creating ideal conditions for struvite formation. And then in this reactor, we supplement and add that little bit extra magnesium, and instantly they start to form these granules and the struvite precipitates out. And so we're capturing it here before it goes to the next process, so I don't have my pipes being clogged and all these downstream tanks being including the struvite. And so that's the process right there. Can you scroll down there, Mary? Is there a, go back up? Is there a play window that pops up right here? Should be a video.
Oh, man.
If you scroll over to the part of the screen, there should be a video that plays.
Let me see if I can click the screen.
You got a mouse?
Yeah, I got.
Where's your mouse?
Hmm.
Where's your mouse? Can you hit your volume up a little bit, maybe? Summit County Wastewater Reclamation strives to be an industry leader in the sustainable management and resources. Did you ever hear that? Public health and safety through excellence. Our nutrient recovery project exemplifies this commitment creating a renewable resource from an otherwise debilitating use of byproducts. It all starts with the well-known element phosphorus. It is the backbone for both DNA and ATP, key components every living organism needs for growth. Unfortunately, nearly all phosphorus needed to produce crops and the foods we eat is mined from phosphate rock. Over 70% of the phosphate originates in Morocco and is exported worldwide, with China in a far distant second place. The United States accounts for less than 2% of the world's phosphate demand, with mines located in Florida, Idaho, North Carolina, and Utah. Without active management of phosphorus resources, these supplies are estimated to run out in as little as 50 to 100 years, making phosphorus potentially more important than oil. While all plants thrive in the presence of phosphorus, overuse can contribute to farm runoff, resulting in pollution of our rivers, lakes, and potentially leading to harmful algal blooms. Phosphorus in the foods we eat is also excreted in the sewage, where it can potentially pollute our waterways. During wastewater treatment, phosphorus can often create a concrete-like substance called struvite, creating catastrophic problems if not managed. Struvite is comprised of ammonia, magnesium, and phosphate. And if you have ever experienced kidney stones, you too have encountered struvite. Treatment plant operators use corrosive chemicals and mechanical processes to combat struvite, which increases the cost of treatment. To solve this problem, Pima County embarked on a comprehensive phosphorus management strategy, utilizing both biological phosphorus removal, followed by a selective precipitation of struvite in a controlled reaction. The nutrient removal system, called NuReSys, is not only a first for Arizona, it's the first installation in all of North America. Captured struvite can be beneficially used as a slow-release fertilizer, minimizing traditional fertilizer usage. This is a significant advantage in keeping phosphorus out of our waterways. Pima County's innovative technology will not only benefit Arizonans, but it will also serve as a model for utilities nationwide, improving our waterways and reducing the worldwide phosphorus demand. And so that's the finished product there. It's been in operation since about March this year, but 750 fewer haul trucks on the highway a year. That was, we were able to increase our percent solids from about 15, 16% to 20% solid. That's a tremendous amount of savings for us in trucks and possibly accidents. We had one roll over in July of this year. But all that phosphorus, 85% of the world's phosphorus, all comes from Morocco. So it's being mined in one place, shipped across the tankers across the entire planet. And so I think it's great. We capture that phosphorus, it goes right back into biosalts. So all of our local farmers, that reduces their phosphorus load. And they're not using an inorganic type phosphorus that will then lead to farm runoff. This is a slow release, organic and everyone else outside. Next slide. Our biogas. So biogas, methane that comes out of the digesters is 60% methane, 40% CO2. And so typically a lot of facilities will burn it in their own engines, cogeneration. We did that at Tres Rios for about 25 years. When we built these new facilities, the air quality permitting was so onerous that it didn't make it feasible. And so we've been flaring that gas, just wasting it, sending it to the atmosphere since 2014. One of the treatment plants we were at yesterday in California, they did cogen as well until EPA changed their regulations. They can no longer use it for cogen. And so they're burning it in boilers and stuff like that. And so this is a 3-stage membrane process. You really have your pressure swing absorption, vacuum swing absorption, single stage, second stage, and third stage. We went with the third stage. First stage will get you about 85, 89% pure methane. Second stage will get you around 95% pure methane. We went to the third stage to get us 99% methane. So we're putting real high quality gas in the Southwest gas pipeline. Then we sell that gas in for the RIN credits. You get D3 or LCFS credit. That's low carbon fuel standard in California. So we make money on this. So this process is probably going to generate around $3 million a year in revenue. That's revenue that we reduces our need to raise our rates and our rate structure to help maintain our utility. Then we also partner with a local artist here in Tucson. Many of you have seen Ignacio paintings around town, the piñatas chasing the kids around town, or if you've ever been to like Guadalajara Grill, you see those nice paintings on the wall. So Ignacio painted this. We titled it Evolution to Clean Energy. So it starts out with fossil fuels. Then you see the 1950s gas station there burning those petroleum fuels. You see some nuclear and some, polluting the atmosphere, and then the clean Santa Cruz River on the back end that we were cleaning up there. So it's called Evolution to Clean Energy. They gave out printed forms. Printed of it. Southwest Gas was our partner on that. And that project, we started probably in November in earnest. Last night was the first night we ran 24 hours a day. And so we're slowly geared up to having run 24 hours a day, 365 days a year, and put beneficial use to that gas. Next slide. So this is the NuReSys process. First step, so the gas is typically 60% methane, 40% CO2, but it also has hydrogen sulfide and some impurities in there, siloxane and stuff. So this is the treatment process. Ferrosorb, it's an iron oxide. The gas goes through it. It creates a ferric sulfide with the hydrogen sulfide that's in the tanks. Then we supplement with a little bit of oxygen to keep the rust process continuously going. So it's always creating fresh ferric oxide that will react with the hydrogen sulfide. So we're precipitating out ferric sulfide and sulfate, right? Next slide. Come on, Mary.
Just a minute. Just a minute.
So then this is the actual skid of the treatment process. And so here, these are carbon vessels, GAC carbon, just like we'd use in water treatment when we're pushing air to it. These are going to move into volatile organic compounds and those siloxanes. Then we have a feed gas compressor right here. We pressurize this up to about 250 psi, squeeze it through these membranes. And so when it goes through those membranes, these are embonic gas membranes. It extracts out the CO2 that gets fed into the atmosphere. The methane then gets compressed again to about 400 psi, injected in the Southwest Gas pipeline. So this is brand new, just started up a few weeks ago, and last night was the first night we run it continuous 24 hours a day. Next slide. Everybody, talking that. Our last product, biosolids. So all the biosolids we generate get put to beneficial use on the farmlands out in Marana and in Casa Grande. But we're seeing a real problem in Arizona, we can only apply our biosolids to privately owned land because we make a Class B product. In order to apply to state land that's farmed, you have to have a Class A biosolids product. And so when a new highway like Interstate 11 is slated to go right through Abra Valley where all of our farmlands are, it's going to be the private lands that are sold off first. And so I've got a need to, I've got to move to a Class A product. And everybody's heard about PFAS in groundwater, right? Tucson Water struggling with it, Marana, very expensive, nationwide, everybody's dealing with PFAS in groundwater. So one of the concerns from our Board of Supervisors was, is our biosolids application, which we've been doing for 25 years, 30 years almost, is it having any impact? Are we concentrating PFAS in our biosolids? Is it going to leach into the groundwaters in the farmland? And so we did a one-year study last year in conjunction with the university and Jacobs Engineering to evaluate it. So we went out and looked at crops that have received biosolids for 20 years, 10 years, different loading rates, and we sampled the soil at 1 foot intervals, 3 foot and 6 foot intervals. And overwhelmingly, you get 97% attenuation within the first 6 feet. So it demonstrated to us that the PFAS was not migrating and was not likely to contaminate groundwater. And so with that study in hand, we also published an academic paper this summer on it, and we were able to resume our land application process. Otherwise, we're taking this material to a landfill, it's increasing our cost, and it has no beneficial use, and it's eating up landfill space. Yeah.
Question, what about for growing crops and stuff, would it reabsorb into the roots and stuff?
So there are some studies that are looking at, they look at wheat and cotton and stuff, but typically we go all cotton fields, so there's no human ingestion of it. So for us, it wasn't that big of a concern, but we have a nationwide study right now that Ian Pepper's leading, Charles Cohart here, And it's, we have NEBRA, Northeast Biosol Association, and CASA, California Association of Sewer Agencies. And there's probably about, is there 5 or 7 utilities? There's Orange County, Pima County, Aurora, Colorado, Gwinnett County, Georgia, and Loudoun, Virginia. So we've got a good sampling across the country of utilities that are participating in this work. And we're going to do this nationwide study looking at both soils and crop update too. We want to know, is it 22 crops? I don't know. And so we'll evaluate that over the next year or two. Here's the Class B production. So here's my challenge right now, while we were in California yesterday. Currently, my biosolids is 20% solid material, 80% water, right? I centrifuge it, but that's as good as I can get it. That requires 8 to 10 trucks leaving Tres Rios every day heading down the highway. There have been some incidences in California where a truck spills material, the tailgate opens or whatever, and hit the brakes and it spills on the highway. We use polymer to thicken this up. And that polymer is almost like baby diaper gel, so it's slippery. So then a car comes behind it, hits that, and the brakes, people die in their wrecks. And so this has a huge liability for us when we have that many trucks leaving the highway. This was in July. Luckily, he rolled on a farm field, not on a highway. But all this can happen. And so with this scenario, and knowing that my farmland is slowly being urbanized, being sold off for development, I need to make less biosolids, and I need more outlets to distribute it, right? And so going to a Class A, I've taken this 20% figure to an 80% figure, and I've reduced my moisture from 80% to 20%. That would require me to only have 2 trucks out on the highway any given day. So this is my goal. And by making Class A product, all that statewide that's leased to farmers to farm right now, they're an available avenue for me to dispose of biosolids. And then farmers get the benefit of this slow lease for fertilizer. And so that's what we're trying to do right now. And our idea is to build a greenhouse. This is a cartoon of some legitimate ones. We just saw 2 in the last 2 days in California. Surprise, Arizona's got a really unique one that they did as well. But essentially, the biosolids come into the greenhouse. You let sunlight, or you can also have a heated floor. You're driving this moisture out of the biosolids into the air. Then the air gets scrubbed through air scrubbers and evacuated. And so our goal is to take that 80% moisture, reduce it down to 20% so that I can haul fewer trucks out there. By making it a Class A product, one thing that we've also seen is people have pelletized it. And so you make these real small pellets, they can then put it on golf courses, people can get it at nurseries and stuff like that. So it gets a whole lot more opportunities for usage of biosolids. It's recovering of natural resources. And so this is where we're focused right now. We'll probably go out to bid with some designs on this in July. We're trying to partner with Surprise right now to send some of our biosolids material. I'd like to send like a truck over there a month for the next few months, have them dry it, take that material, send it out to a contract labs, and have them demonstrate, yes, this will make a Class A product. And if it's close but not quite, well, then we'll look to put a dryer on the back end or maybe a pelletizer. But those are the processes we're looking at right now.
What kind of footprint would you expect for?
So very nice. So if you've been to Tres Rios, we have regional solids handling. All the solids handling for Pima County is done at our Tres Rios facility. And so we're lucky enough to have a landfill right behind us. The landfill's being closed. And so we're helping the landfill out. They were gonna have to do it in 2 different projects, haul dirt in, and then wait till they get funding to cover the landfill to close it. So we stepped in and said, we'll cover your cost if you let us use your landfill when you're done with it. And they said, okay. And so we'll be covering the landfill between now and next September. I think that's going out to bid. I think the walkthrough is in 2 weeks. Once the landfill's closed, I can then come to build a greenhouse on top of it. I can put solar arrays there to help run this process and everything. So that'll all be going on at Tres Rios over there on a closed landfill. So putting that to beneficial use as well. So that's just the kind of environmental stewardship that we're trying to do. My goal is to try to make this new process completely energy neutral. We would have solar arrays to run the fans and maybe concentrated solar to help heat heat the air up in there to even get it above what, sunlight can do. Yeah, go ahead.
This is fascinating, I have lots of questions, but what is the difference between A and B then?
Pathogens.
Oh, okay.
Yeah, so, and shame on me for not remembering, if anybody else does, chime up. Class B, it's less than 200 NPNs per gram or something like that. So it's stabilized biosolids, right? But if I give some biosolids and I add moisture to it, there's still gonna be some bacteria that survive. And there's a limited threshold, I think it's 200 NPN is the limit. And it may be per kilogram or gram, I can't even remember what it is, to tell the truth. Class A, there's no pathogen. And so class A, to qualify for it, you have to heat that biosolids to 90 degrees for 30 minutes. That kills everything. And so what we're trying to do is get out that moisture and desiccate these bacteria so there's no regrowth at all. And it's got to be tested for Helminthova and different viruses as well.
So as a water resources professional, I just have to ask, is that moisture capturable? How much is that? The moisture that you're evaporating into the air?
Well, it's a lot. So every day I make around 180 wet tons, equivalent to be 46 dry tons.
I have no
And so it's
idea what that
140
is.
tons of water is what's being extracted off there. So you could, on the exhaust fans leaving this, you could have a vapor recovery system
There's
on
a
it.
vegetable garden out there
You
somewhere.
could,
That
absolutely.
would grow.
Because we're just worried about getting the ammonia odor out of it, in the atmosphere, but you could very well put a condensate there and capture 140 tons of water every day.
And it would have to be engineered, of course, for your seasonality, because your cooler months, your evaporative abilities might be a little.
Yeah, so what's kind of neat, the one in Surprise, they have a concentrated solar, right? So they're heating liquid. That liquid then, there's a heat exchangers under the floor, metal heat exchangers. So they're heating the floor to like 150 degrees. The air inside there from sunlight is probably 90 to 120 degrees. And so the footprint of your greenhouse just got really small because you're heating from the bottom and the top. So that's kind of neat, and they're doing it all with solar. And so that's our goal, is to do something similar, but make it all energy neutral. So as we're adding these new processes, we spend probably at Trace Rios about $2.6 million a year in electricity. So our next big push is to say, we're doing an energy audits to see where's our energy used in every part of the treatment process, and what can we do to address these components to reduce their energy consumption. And so, otherwise, as energy prices increase, now your sewer rates are going to have to increase to help offset that. So the more we can do to decrease our energy need and do projects like the biogas, which creates a revenue stream, that helps offset any kind of future rate increases. So that's our goal. I think that's it.
Question?
Any other questions?
The struvite, just a funny note, those cross sections, I've seen them for sale at the gem show. They take these pipes, they're beautiful, the crystal cross sections, and they sell them and people are hanging them on their walls. We have one in our office.
I'll give you all you want.
I'm saying, in terms of revenue streams, here's your future revenue streams. But what are you talked about haul trucks for the struvite process as well. So what are those haul trucks doing? What are they hauling?
They're hauling biosolids. But because of that NuReSys process, you have monovalent and polyvalent cations. Because we're precipitating out the magnesium, it allows us to get up to higher percent solids. And so we gained about 4% extra solids. That's more solid, less water, and fewer trucks on the road. I'm a chemistry major, so I kind of get stuck in the details here and bore people, but that's what I do.
Well, since you're gonna produce Class A, are you gonna sell that then? That allows you to put it anywhere you want.
Yeah, some places sell it. They sell it more as like a marketing campaign, just to show how good the utilities are. I don't think it ever makes any revenue, but a lot of utilities, they'll sell it. You can go to your Home Depot and you can get, they always call it some kind of grow name, you know what I mean? And they do it just to kind of marketing for their utility. If you have a nearby, if there's a turf farm near you and stuff like that, absolutely. You can get And a lot of people sell the struvite. They sequester the struvite and capture it and sell it directly to the, if you put lawn fertilizers in the white pellets, right? And it's the phosphorus and potassium and ammonia concentration. And so they'll sell it, but you really got to have a fertilizer manufacturer within 90 miles, otherwise you lose the profit on the transportation costs. And so we just give it right back to the farmers who, they've been our friends and they've been our source of partners for 20, 30 years. We want to maintain that because we definitely don't want farming to vacate the valley because that's bad for everybody. The more we can help them stay in business longer, you know, they're having a hard enough time right now with reductions on the Colorado River and climate change and droughts that we're having. So we don't want to see farming vacate Arizona for sure.
Just a note on that, I grew up in Milwaukee and we always bought bags of mill organic.
There you
Is
go.
what it was called, yeah, and I didn't realize.
That's Class A biosolids. Yeah, you buy it from
And that
them.
was in the seventies and eighties, they've been doing that for decades. How about potable reuse? You talk about your wastewater stream and quality of your effluent.
So we did it as a demonstration in that truck that we took around the country. We were able to get, we won the Governor's Award, I think in 2017. We were able to get legislation changed, so DPR is a possibility in Arizona. I think Scottsdale had the first, we had the first permit in the truck. But now Scottsdale's got a permit, they're doing it. Idaho copied exactly what Arizona did. We took the truck there and demonstrated there. So we're trying to get DPR. There's still that kind of, a lot of people have that gut factor. You know, that sounds gross. But once they see the process and they see how achievable high quality water is and what low amount of cost, they instantly become comfortable with it. And typically what we saw, we had a large educational component that Chana ran, and it was the 45 and olders were the ones that were kind of hesitant, but by the end process, they started to get it. Anybody in their 20s and 30s, they've been growing up and studying stuff. They're like, no problem. I trust it. It's clean. And they look at the test results, and it was the older generation you had to convince. So, it was funny. I'd go to a conference, I'd bring in bottled water that we made in our process. And I'd hand out bottled waters. People would look at the label and they're like, cool, they put it in their backpack. Then I'd do my talk. At the end, I'd open the ice chest and pull out the beer that was made that water. And everybody's crying. They wouldn't drink the water 30 minutes before, but they'll drink the beer made in that same stuff. So it's just it's a human psychology. It's kind of fun.
Anyone else?
Thanks for inviting me.
Yeah, thanks for coming.
If you guys ever want to see Trace Rio, stop by. We're doing a lot of neat stuff there all the time.
And you give tours, right?
Always, yeah. But I always say we have an invisible utility. If it doesn't stink, sewage isn't overflowing in the streets or your house, and I don't raise your rates, you don't even know we exist. You flush the toilet, you take your shower, and the water goes somewhere. You don't think about it until you raise your rates, or it doesn't work when you flush, or you smell something when you go down the street. And so we do have a webpage and a hotline. If you do smell sewer odors around the city, you call that hotline. We dispatch a crew to investigate it. Jaime's group in our conveyance, we've invested. We funded a U of A senior design project 2 years ago, and then COVID ruined it because all the U of A closed down, and we had to cancel the whole internship program. But our goal was, just like you have an Uber app where you can see the city and where the Uber cars are, we wanted to install these odor monitors all around the city, H2S monitors connected to our Arduino board that would then send out a 4G cellular signal and tell us what the H2S levels were throughout the city. So we know we have some problem areas that are prone to sewer backups. And so if we start to see H2S levels rising, we'll probably say, uh-oh, we better send a crew out to clean that line, right? And remove the blockage. And so COVID wrecked that. And lo and behold, a company called Smart Cover now makes these they have a little iridium satellite antenna that mounts on top of the manhole cover, and the sensor is right below it. And so Jaime has these in the collection system. We probably have at least 100 of them right now throughout the collection system, upstream and downstream of some of our chemical dosing units and vapor recovery units. And so they'll see the H2S level increase. it'll start feeding more chemical, and the level comes back down, so we're controlling H2S and odors throughout the collection system. So kind of neat stuff, and we try to partner with the university and do a lot of these stuff in our R&D developments and doing a lot of neat things.
I'm gonna end the recording.